Hello there. This is my first video on Exercise1C for the days I'm going to be away: Monday, Tuesday, Wednesday. Now, let's just get some things sorted. So, what you should have gone through so far, at least understood, is 1A. We went through set notations and interval notations. Yeah. We looked at how to read these notations and how to use them for domain and range. So if you worked on those exercises, they should go through, how to look at how to write them on a number line, how to read the equation, sketch the equation, read the domain, read the range, and describe them using either set notation, interval notations, or both. Okay, and then we moved on to 1B, and I talked about what a function was and what a relation was. Okay, so these were the two things that we sort of talked through, and I said that this is one of the bigger things to understand. Along with that, I then taught you 4 types of relation, which actually that actually fits into 1C. Okay, so that's in 1C, and we talked about implied domains as well, and how to write them as function notation. That's 1B, 1C. Yeah, but I taught them separately. I taught this as one chunk, and then I made a video for 1C for another class. So one of my classes, I haven't actually taught it in class, but I have made a video for it with another class, if that makes sense. So if I remember correctly, I think it was 12D, 12D, Class D. You haven't had me describe hybrid functions in class, but I did describe it to 12E, and that was recorded. So there's a video there for you. But otherwise, I'm going to do examples in 1C anyway, so that you can see how I do it. And hybrid functions will be there too. So hybrid and odd / even functions. Okay, so watch the video for 1C. If you haven't watched 1C, these are for students who are from 12D, okay? But everyone should have had the same description or understanding for functions versus a relation. There are 4 types of relation, and you also were taught how to use function notation, yeah? That's in 1B. And so today I'm just going to go through 1C as your examples, 1D examples as well. Now, providing I have enough time, I may do 1B examples as well. Otherwise, I'll catch up on that when I come back. Otherwise, post it up in your discussion folder, and hopefully we can help each other out. I'm not sure if I have internet while I'm on camp and whether I have time to look at it anyway. But remember, the discussion area is for us. We work as a team, and where I can't answer yet, if you guys can help each other out, that'll be fantastic. But that's the aim. So I'm going to go through the examples so that we've sort of consolidated our understanding of 1A, 1B, 1C. 1D is just tedious. Okay, it's not a concept that is too hard. Most of us will understand what we need to do. It's just tedious to do. Okay. And 1E, I'm going to leave that till I come back because that's composite functions, and that is probably one of the hardest ones for students to understand, along with modulus, but I believe they've taken modulus out of the course, so you still need to understand what it is too anyway. But 1E is the harder one. So I'm going to work on 1C, 1D for this weekend, and some of you are missing, I think it's 12D, you're only missing 2 classes, whereas 12E, you guys are missing 3 classes. So as long as when I come back, you have 1A, 1B, 1C, 1D up your sleeves, that's pretty good. Okay, that's pretty good. And then we'll work on 1E when I'm back. All right, here we go. So let's start. Exercise 1C example. So basically, I'm going to go through the examples from the textbook, so you can obviously look at those. I'll do it with explanation, and I'll look at the questions from the exercises, and I'll pick out which ones I think you might have difficulty, and I'll sort of guide you through it as well. Okay. Now, as I'm saying this as well, I'm uploading the work solutions for the textbook, sorry. So the work solutions for the textbook, Cambridge has a work solution, so step-by-step solution, how they do things. Now, it's rarely some of the questions, they just have the answers. but it's a good point of reference just to have a look and see if you're doing it right and whether you're on the right track, or if you had no idea, you can have a look at it as well. So that should be uploaded in your textbook folder, and there's a green folder that says Work Solutions. Click on that, and you should have a bunch of chapters there, but it's uploading right now. So while it's uploading, I'm making this video. Okay. Here we go. Let's look at example 9 from exercise 1C. So for each of the following, sketch the graph and state the range. Now, some of you, sketching graphs might not be your forte just yet. You can use a calculator and sketch the graph. Now, notice this is function notation. Where I left both of your classes, I have taught what function notation is. Notice again, that's f, so they use f of x. That was g, so they use g of x. The x just tells me that I have x's in the equation, okay? So usually what you would normally see is y equals to 2x minus 4, and this would have been y equals x squared, and they tell you the domain, okay? So this is your domain, this is your domain, and this means maps onto your codomain, remember? And I said that you're always going to have R in methods, okay? So if we're looking at this, they're just saying sketch the graph and state the range. So it's pretty straightforward in the first question there. It's about just reading the notation and knowing what you need to do. So for me, I know this is a straight line equation. So if I just went with y equals 2x minus 4, if it's a straight line equation, I know that, I need a y-axis intercept and an x-axis intercept. So I can clearly see the y-intercept is at -4, so -4. And I know that the x-intercept when y is 0, so when y is 0, I've got +4 on both sides, and then divide both sides by 2, so x equals 2. So I'll let y equal to 0 because I know to find the x-axis intercept, the y-coordinate is always 0. So that's what I'm saying. I know the y-coordinate is always 0. So on the x-axis, any x-coordinate, as in any coordinate, the y-coordinate has to be 0 on the x-axis. Yeah. So I solved it. I just found out x equals 2. So I know now 2, 0 is my axis intercept. Yeah. So I'm just sketching the graph. Now you can do this on your graphics calculator. You can type it up. I'm just doing it by hand right now. Later on, I'll use a calculator as well, so you can see how I use them. So there we go. We've got a positive gradient. And normally the graph would look something like this. It goes infinitely. True? Both up and left. But be careful, especially in your sacs. Here, you've got a domain. So there's a restriction. And the restriction is it starts at -2. So let's say -2 is here. It is inclusive. It has a square bracket. So that means it closes off here. Okay. And then it finishes off at 4 as well. So it doesn't go on infinitely. It actually finishes at a certain point. So let's say this is 4 here. Right? So note, I'm not actually drawing it to scale as well. So that means you need to draw this straight line. So sketching the straight line, it has to be the blue line that I'm sketching right now. So it has to have this. They don't tell you to sketch it with the axis intercepts. You can do that. I'm just doing it so you can see. But what we need to know now is we want to find the range. Now, we know this is at 4, but we don't know what the y-coordinate is. We know this is at -2 for the x-coordinate, but we don't know what the y-coordinate is. Yeah? So the only way to find the y-coordinate, because the question says state the range, is if you substitute it into the equation. Because the equation says, I'll tell you what y is if you know what x is. So x is, whatever x is, times by 2 and then -4. That's what the equation tells me. True? That's what the equation says. So if I know that x is going to be 4, the question is, well, what's y? So if I answer that question, I'm like, okay, well, if x was 4, then that now gives me y is equal to 8 minus 4, which is 4. So I know now it's at 4, 4. And then when x is -2, okay, when x is -2 there, I can say, all right, well, at -2, y equals 2 times -2 minus 4. And that gives me what? -4 minus 4, -8. Okay, so that tells me now, I know this coordinate here is -2, -8. Okay. So looking at that, I now know the range has to be from -8, which is on the bottom, -8, all the way up to 4. And that's my range. Okay, so to answer the first question, I'd say A, y's element of negative, so inclusive, -8 to 4. There you go, that's my range. Okay, so everything that I'm writing on this page here, that I should be seeing your exercise book. I don't want to just see an answer. I want to see some sort of working solution. They do say for each of the following, sketch the graph. So sketch the graph. Even if you have to do it very, very skimpily, I want to see a graph and I want to see how you're finding the range. Okay. All right, let's do B now. So if I were to do B, same concept. B, it says not inclusive at -1. Okay, and the graph is an x squared graph. So with an x squared graph, this is what a parabola looks like, y equals x squared. Okay, I've got -1, so let's say -1 is here, and let's say 2 is over here. It's inclusive at 2, but not inclusive at -1. So really my graph looks like this. I've got not inclusive at -1, all the way up until 2, and it's inclusive. Okay, so just ignore the blue line. That's what my graph looks like, and I want to find my range. Now clearly the range looks like it's starting at 0 because I know it's an x squared graph, so 0. I just need to know what the value is when x is 2. See the highest y value here, what is that highest y value? That's what I'm looking for. Where's my highest y value? So I know when x is 2, 2 squared, and if I substitute into the equation, y equals x squared. If x is 2, 2 squared, which makes it 4. So I know my range has to be between 0 and 4. Now be careful here, okay? A lot of students just naturally jump to saying the answer is 0 to 4 and inclusive, and it is correct. You just got to be mindful of anything that's exclusive, yeah? So in my case here, I can see that, yes, I can't have a -1 here, but I can have, whatever this value is, so when x is -1, this coordinate here, -1, then y is also 1. So yes, though the y coordinate at this point is not inclusive, but the y coordinate on this side is inclusive. This one has 1, 1. That's inclusive. Okay, so that means the range from 0 all the way up until 4, there's a y coordinate for every one of those points, if you know what I mean. So what I'm trying to say is, whoops. Oh my god, what happened? Okay. Every y coordinate, there's a pair everywhere. Okay, so there's a coordinate at every single point. So the y coordinate exists for every single coordinate up until 4. So my range naturally would then be B is y as an element between 0 to 4, all inclusive. Okay. So that non-inclusive symbol doesn't apply in this case, only because it's a quadratic. Okay. If it wasn't a quadratic, let's say the graph finished off at, let's say, something like this. If I do it like this. Okay. If I stop there, obviously my range would start from 0 all the way to 1, which is the highest point, and it'll be inclusive or exclusive at 1. Inclusive, what the hell does that mean? Exclusive at 1. Okay. All right, there you go. So I've just answered 1A, 1B, not example 9A and B for you there. Hopefully that kind of makes sense, domain and range, sketching the graph. And again, all of this you can type on your calculator, get the idea of a graph. I'm just doing it by hand now. And it's good to know how to do it by hand because eventually you're going to have to do it by hand. So if anything that I'm saying here, you're unfamiliar, work with it, yeah? Play with the algebra, play with the fractions. They're very important for your later stages, okay? Here we go. Now, next part. Types of functions and implied domains. Okay, so this is 1C. Remember a function, I talked about the machine, that doesn't matter how many x's you put in, you only want one y value to come out, okay? Now, it says, which of the following functions are a one-to-one? Now, just keeping in mind, if it's a one-to-one, so they're both faithful, if you remember, x is faithful to y, and y is also faithful to x. That's a one-to-one. That means you shouldn't see any repetitions. There should not be any other x is not paired with another y value, so x is not being repeated in terms of coordinates. Like, for example, if I gave you this graph, you see, if this would be for the same x, there's two coordinates here. You have x and a different y, so let's say y2, y1 there. Then this is y2, and this is the same x with a y1. See, there's a repeated x coordinate there. This is not a function, that's a relation. So the first thing to know is, well, how do you know if it's a one-to-one function? Is if you look whether there's any repetitions on your y-coordinates. You know, because if there's repetition on y-coordinate, it means x is polygamous. X is cheating. X has y1 and it has y2. So that's what you're looking for. So if I look at the first one, I'm like, well, that's -3, 7, 6, 10. Okay. I'm not checking if it's a function or not because it says which of the following functions. So you already know they're all functions. You're now just checking it's one-to-one. So answering this question, clearly, -3, 7, 6, 10, none of it repeats. This is fine. A is clearly a function, and it is also a one-to-one. One-to-one. Okay. So x is faithful. 2 to -3, 4 to 7, 6 to 6, and 8 to 10. Yeah. Actually, did I say repetition of y? No, whoops, sorry. I'm talking about repetition of x, obviously. So it means like if you put in one x value, you get two y values. So any repetition of x means that it's a 1-to... If there's a repetition of x coordinates, it's a many-to-one. Wait, no, not many-to-one. One-to-many. One-to-many. So 1x to many y's. That's a relation. Okay, so that will tell you if it's a function or not. Oh, yeah. And if you... Yeah, no, I was correct. If you want to know if it's a one-to-one, you'll be checking the y-coordinates. If there's a repetition in your y's, does it have... if it has repetition in y's, so for example, like this is a many-to-one. So this is y. So let's call that y1. This is now x1, x2. So you can see that y1 is paired to, say, y1 has two partners. It's with x1 and it's with x2, meaning when I put in x1 and I put in x2, I only get one y. That's not a one-to-one. And you can see that if I were to write the coordinates, it's x1, y1, and this is x2, y1. Repetition of y's means it's a many-to-one. So that's what I'm looking for. -3, 7, 6, 10. And they don't repeat the y coordinates, so it's a one-to-one. Okay, it's not a many-to-one. So if I look at B now, I'll look again. 4, 5, 4 again, and 7. So there's a repetition of y. So that means the y coordinate 4 is actually polygamous. It's a many-to-one. It's actually cheating. It's gotten with 1 and 3. So this coordinate here, it's with 1, and it's also at 3. So there's a 3, 4, and a 1, 4, which is what we don't want. Okay, so as in if you want it to be a one-to-one, it's not a one-to-one. 1 is faithful to 4, 3 is faithful to 4, but 4 is not faithful. 4 is with 1 and 3. Okay, so that's a many x's, so 2 x's to the 1 y value. Okay, so it's a function, but it's a many-to-one, not a one-to-one. So B is a many-to-one, not one-to-one. Okay, let's have a look at the next example. Here we go. Which of the following functions are one-to-one? So now you don't have coordinates, now you're looking at the graph. Now each one of those, if you can sketch it immediately, great. Otherwise use a calculator. For me, quadratic equations, we all know now, this is a many-to-one, because you can see for one y value, it's connected to many x values. So x and an x, so that means in your box you have 2 x's, you get 1 y value. So it's many x's to 1. Okay, so many x's to 1 y. Therefore, A is a many-to-one. B, obviously I'm answering the question as it's not a one-to-one. So A is not a one-to-one. Let's have a look at B. B, 2x plus 1. So I can tell that y equals 2x plus 1 is a straight line equation. If it's a straight line equation, it has a y-intercept at 1. That's clearly a one-to-one, you know, for one x value, it's connected to another y value. Okay, and there's no repetitions x, no repetitions in y. That is a one-to-one. So B is a one-to-one. Okay, so this is... Oh no, something's happening with my mouse. No, okay, it's all good. One-to-one. So we can go 1-to-1. All right, so C f of x equals 5. That's a straight line. It's just saying that the y-coordinate is always 5. So if the y-coordinate's always 5, it looks like this. See, at this point, 1, 5. See, the y-coordinate's 5. At this point, 2, 5. Again, y-coordinate's 5. So if you draw it out to a horizontal line, it's a linear line. So this is now not a 1-to-1. It is a straight line, but in this case here, you can see for one y, you have many x's. Many x's. Okay, so that means many x's to the one y. So this is a many to one. So not all linear graphs are 1-to-1. Okay. Next one, D. You can see x cubed. So you draw out your x cubed. You have a look, x cubed there, and you can see for every x, it is connected with one y. So this is a 1-to-1. 1-to-1. Okay. E. This is square root of 9 minus x squared. If you actually rearrange this, squaring both sides, you get y squared equals 9 minus x squared. Plus x squared on both sides, you get y squared plus x squared equals 9. This is a circle, okay? But when it's written in this form, that's a semicircle because the square root is a positive. And it says it's a function, okay? They didn't say relation. If it was relation, that could have been a circle. But in our case, this would be a semicircle where it's the top half of the square root and the radius is 3. So if I were to sketch this graph, it's like this. Okay, so if you type in your calculator, it should look something like that. Okay. And so we can look at that and say the same thing again. This is a many-to-one. You can use a horizontal line test if you've forgotten. You can see that for one y value, it's connected to many x values. Okay, so it's a many-to-one. So E is a many-to-one. All right, and then finally, 1 on x. F, 1 on x function, that's a rectangular hyperbola with asymptotes at the x-axis and asymptotes on the y-axis. Okay, and you can see that that means it's a 1-to-1 as well. Okay, so for every x value, there's only one y value. And that's a 1-to-1. So F is a 1-to-1. So answering the questions, which ones are 1-to-1? You've got D, you've got B, you've got F. Okay? So again, I can do all this because I can sketch all the graphs and I can analyze that. If you couldn't graph it on a calculator, learn to graph it by hand though. Eventually, before your SAC 1, so end of term 1 and somewhere mid 2, you have to know how to do all this by hand. So whatever I'm doing right now, you should be able to do what I did. Okay? But the foremost important thing is to understand what a function is and how to tell what type of relation you have. Okay? All right. Next one. Find the implied domain and the corresponding range for the functions with rules. Okay, so in this case, you're now looking for implied domain. So they don't tell you what the domain is, but you have to sort of figure it out. So it's all through graphing. The better you can visualize the graph, the easier it is to answer the question. So 2x minus 3, I can tell that the y-intercept is at -3, and it's a straight line equation. So, you know, it has no restrictions at this point. So therefore, domain, it can take on any real value because x can be anything. X could be a negative, x could be more negative, x can be over here. You still have a coordinate on the straight line. Okay, so x is an element of all real values. Okay, so I'm using exercise 1A to answer the question, appropriate x element of real. Okay, B. If we have, look, that's a truncus function translated by 2. I know some of you might not have been used to this. Again, use a calculator. It's a truncus function and has an asymptote, vertical asymptote at x equals 2. How do I know? Because if I put in 2, 2 minus 2 is 0, and 0 squared, you can't have 1 divided by 0. It's undefined there. That's why at x equals 2, it is undefined. Okay, it's my truncus function, therefore it has an asymptote horizontally, y equals 0 as well. And if I look at that, and corresponding range, sorry, I forgot. I didn't read the question properly there. And the range is, for the first one, is all real values. For B, I can look at that and say, clearly, your domain can be all real values except for the value 2, because it's undefined there. Whereas your range could be all real values that are positive, because you see the truncus is above the x-axis. All the y values are positive right now, and it can't equal to 0, so it's R plus. Okay, and that's for 1b. I mean, example 12b. Okay, and then you go to C. it's all about graphing here. So you look at the graph x root of x plus 6. You know, I know that graph moves to the left by 6. I'll teach you all this as well. If you're in my year 11 class last year, I would have taught you how to read transformations. So we know that this is to the left by 6. And this is a positive root graph. So I know it looks like that. And looking at that, I can say that the domain is from, and it's inclusive, and -6 all the way to positive infinity. I also know the range is an element of R plus union 0. 0 to infinity. Okay. And then you go to the last one, you got D, f of x equals to root of 4 minus x squared. That's, if you rearrange that again, that's actually a circle. Just like, it's actually the same as this one. It's just 4. Meaning it's a semicircle. It's a positive because the square root is a positive. So it's a semicircle with a radius of 2 because 4, if you change that to a squared value, it's 2 squared. 9 was 3 squared. That's why I knew the radius was 3. So if I were to quickly draw this, it looks like this, -2 to 2. So if you set the range is from -2 to 2. And I mean, the domain is from -2 to 2. So x element of -2 to 2. And your domain is from 0 to 2. Okay. Your range is from 0 to 2. Domain is from -2 to 2. All right, so you can see everything I've done so far is all about graphing. The better you can graph it, the better you can do. And all these graphs you've learnt in year 11. Okay, it is a good idea to, if you've totally forgotten some of the properties, go back to year 11 textbook because it's more in depth. Whereas in year 12 it gets a bit more tricky. So you can go back, have a look at each of those graphs, try to remember the properties, remember how to sketch them. That's chapter 5, gallery of graphs. If I remember correctly, if not 6. No, I'm pretty sure it's 5. 6 is your circular functions. But you have to be able to sketch these graphs, especially for your SAC. You have to know it inside out. You can't rely on your calculator all the time. And if you don't even know how to do it on your calculator, you're setting yourself up to fail. Okay? You got to learn how to sketch. Everything that I'm doing right now, it's all a building block. You learned exercise 1A, but you can't do it if you can't sketch. Yeah? Sketching is important. All right, next one. Let's go to the next one. So find the implied domain of the functions with the following rules. So same thing, f of x equals to 2 on 2x minus 3. Now, I've just noticed I said that if you can't sketch, you're pretty screwed. And I said if you can't do it on your calculator, you're very screwed. So I've been doing it all by hand. I'm going to show you how to do it on a calculator as well. So at least you can do these questions and consolidate exercise 1A and 1B. But here we go. So let's say I want to sketch these. So I've done it all by hand so far, right? These ones, draw them out. I can sort of figure it out just by looking at the properties. So sometimes I don't draw it at all. I just look at it. So for example, I look at this and I know that if you have a fraction, as long as the restriction would always be that the denominator can't equal to 0. So what number would x have to be to make it 0? Well, 2x minus 3. For it to equal to 0, x has to equal to 3 on 2. Okay, so I know that at 1.5, if you subbed in 3 on 2 into the equation, that denominator would be 0. So what I'm saying is, if you have 2 times 3 on 2 minus 3, if this is the function, right, and I said substitute 3 over 2 into the equation, see double 3 over 2, or double 1.5, that will give me 3. Minus 3, and the problem to that is you can't divide anything by 0, so it's undefined. So obviously it says find the implied domain because, well, I know that at x equals 3 and 2 it doesn't exist. They just can't work. So I know for any fractions you just can't have a denominator equal to 0. So that's the first thing already. So I already know A without even sketching the graph. I just know x is an element of all real values excluding 3 on 2. Okay, that's how you answer the questions. Whereas square roots, we all know square roots, we can't square root a negative value. And that's what you're looking for. You just want to make sure you can't square root a negative value. So the tricky one is D, but I'm going to do B with you. So B, if you have a look as G, If you can sketch it, it makes it easier. But if you can't, you can analyze the equation. You see, 5 minus something, what number would you have that makes it negative? You see, 5 take away 4 is positive. 5 take away 3 is positive. 5 take away 5 is 0. So naturally, anything bigger than 5, 5 take away 5.1 will make it a negative. So you know that any number that is bigger than 5, the whole thing is going to be negative. And you can't square root a negative. Okay, you can't square root a negative. G of x will be a negative. So because you know you can't square a negative, so for example, if I said x is equal to 6, if I substitute 6 in, what you can see is g of 6, 5 minus 6, root of negative 1. We can't do root of negative 1, so it's undefined. So that means 6 doesn't exist. My domain can't have 6. All right? But then there's so many to list. There are infinite numbers. So how do you say that? I know the answer would just be domain can be anything smaller than 5. It can't be bigger than 5. Okay, so anything bigger. So 6 was bigger than 5. 5.1 is bigger than 5. So all I have to say is x is an element of, if it has to be smaller than 5, well, you can do this. Negative infinity up until 5. And it can be 5. You can have 5. Okay, but you can't have anything more than 5. And if you sketch the graph, it would have been easy to see. So the graph of 5 minus x actually looks like this. Whoops. It's a square root function, and that's at 5. And that's how you describe the domain. See, if you can visualize the graph, answering the question is easy. If you can't visualize the graph, you can see how hard it is. Like now it comes down to algebra, and a lot of the times, you know, finding out the implied domain, you have to know certain properties. And some of the properties are square roots can't be negative. Fractions, you can't have denominator equal to 0. That's where your asymptotes are. Yeah. So let's say if you couldn't sketch the graph by hand, like I just did, and you can't analyze the equations yet, then step 1, start sketching it on your calculator, but you must learn how to sketch by hand eventually. Yeah. Don't rely on your calculator all the time. So the answer for the first one is it can be any number less than 5. Now, how do you sketch every one of those? I'm just going to hit up my calculator. This was for my year 11s, so I'm just going to clear history. Here we go. Show. First thing I'm going to teach you, well, year 11, we learned to define functions. Yeah, so you go to menu, 1, so define a function. Let's say f of x. Okay, so you type in f and you bracket your x's equals 2. And in my case here, I had root 5 of minus x. Okay, so root control x squared there. Oops, no. What happened there? Huh? Delete. Control square there, and then 5 minus x. Press enter, so I've defined it. Yeah? I know you don't have to do all this, but it's good habit. Trust me, just learn to start using define, because when you do your SACs, you're going to define many functions. It could be g of x, h of x. Learn to define it first so that you can find out values. Like, you know, if I subbed in f of 2, what would it give me? And it'll be like, you know, if x was 2, then 5 minus 2 is 3. That's why you have square root of 3. You learn to play around with them. Okay? I'm just going to delete that line. There we go. Now we're going to add a graph. So control doc. And we're going to add graphs at number 2. Okay, I got number 2. Now, because I defined the graph, I just type in f of x, because that's what I said. I just said f of x equals to this equation. Okay, you press enter, and like I said, there you go. So it's 1, 2, 3, 4, and 5. And we know that that point there is at 5. Okay, if you're unsure, you can do menu analyze, and 0 tells you your x-axis intercept. So if you just went from here to there, it tells you, see, it ends right at 5. That's where it crosses the x-axis at 5. So you'll know that it's from negative infinity up to 5. That's my domain. Range is obviously from 0 to infinity, positive infinity. Okay. All right, so there you go. And if you want to do, let's say C, same thing again. You can do C, and you can do, what was it again? Square root x minus 5 plus root of 8 minus x. Okay, now before I press enter, okay, the question is, if you have the graph, obviously you can sketch it and you can figure it out. But what I want you to do is to see if you can, without a cas, what if we were just to analyze the equation? What if you were just to look at this now and say, well, what can I have and what can't I have? Because obviously you got two conditions here. You got two square roots, and we know that when we square root them, there are its own individual set of restrictions. So we have to make sure the restrictions satisfy for both square roots, right? So before I press the enter button so you can see what it looks like, let's go back and analyze this. Let's see, even without a graph, I don't know what it looks like yet, okay? But I can look at the graph and say, okay, h of x is equal to root of x minus 5. This is plus with, or added with, root of h minus x. Now what I'm going to teach you here is the precursor to the next exercise 1D, sums and products of functions. Because you have to analyze them individually and see what works and what doesn't work. See, we say, I'm going to highlight here, we say that root of x minus 5, the only way that a square root for this one to work is if it doesn't end up being negative. So something take away 5 doesn't become negative. Now obviously, 4 take away 5 is going to be a negative. 5 take away 5 won't be negative. 6 take away 5 won't be negative. So where's the restriction? The restriction is when you have it less than 5. Okay, so if I had 4.9 take away 5, that becomes a negative. So here, I'm just going to write my condition here so you remember. The condition, I'm going to do it in blue. So the condition for this one is anything at x less than 5 won't work. Okay, anything less than 5. 5 is okay. 5 take away 5 is 0, square root of that, that's fine. So when x is 5, this is okay. What are the restrictions on this one now? See, now you have to look at this one and say, well, what's the restriction there? Now, 8 minus x, if you have another square root, you have to look at it and say, well, what's the condition here? You can't have a negative, so 8 minus 1 will make it negative. And again, in this case, 8 take away 7 is fine, 8 take away 6 is fine, 8 take away 8 is 0, but 8 take away 9 doesn't work. And clearly, the restriction is if x is greater than 8. For example, 8 take away 8.1. See, that will become a negative. We don't want that. That won't work. Whoops. Where'd I go? Okay, this won't work. So if you put the two things together, if I draw on a number line, I said, for the first one to work, for the first square root, x just can't be less than 5. Okay, so less than 5 is an issue. Less than 5 is an issue, okay? Having it is okay. Less than 5 is an issue. The other one says it has to be greater, but if it's greater than 8, so 8 and above, greater than 8 and above, that's an issue, okay? So the question is, well, what numbers can you work with? Clearly, what I've just drawn are the things that won't work. All these numbers here don't work, all these numbers here don't work, so what numbers work? Clearly, between 5 and 8, inclusive. 5 works and 8 works, okay, because 8 said, just make sure the number's not bigger than 8. It can be 8, but not bigger than 8. So clearly, the answer has to be between 5 and 8. You see, I'm just using logic here. I'm just working with the conditions that I know. Square roots can't have a negative, and I can see where it works is between 5 and 8. Okay, so let's see if that's true. If I sketch the graph, it should only have a domain between 5 and 8. So let's check. I'm going to go here, press enter, and hello, look at that. Okay, I'm just going to zoom in, and then I'll just move this graph across. Okay, so look at that. It's only between a certain value. Now, I know you don't know what the values are, so we're going to go with, again, menu, 6, 0. Actually, oh, this is not 0. It wouldn't work. It's not on the x-axis. We can do menu 6. How do we look at the endpoints? Maybe we will do trace. Let's do trace. So trace gives you like specific points. If you just keep moving forward to the end, yeah, there you go. That's at 5, x equals 5. And that's what I said. I said there's going to be a coordinate between 5. And if you move trace all the way to the other end, whoops, I've just passed it, to the very end. There you go. The last point is 8. The graph only sketches from 5 to 8 because those are the numbers that work. Those are the numbers when you put into this equation, neither of the two square roots is undefined. Because remember, how do you add two numbers that are undefined? For example, I'll give you an example of what I mean. So let's say we pick 0. Okay, we pick 0, x equals 0 as our value to put into the machine. Okay, so in this machine, I'm putting in x equals 0. Let's see if it works. Okay, I sub in 0. Now the machine is h of 0. Then what it will spit out is h of 0 will equal to root of x minus 0. So that's what the equation is, x minus 5, sorry. So it'll be 0 minus 5 plus root of 8 minus 0. And the problem with here is it's undefined because you can't do root of negative 5. Undefined plus root of 8. See, that's a problem. What's the answer? I don't know, undefined plus root 8. I have no idea what that answer is. That's why all of these values here less than 5 doesn't work, and all the values above 8 doesn't work. It has to satisfy both equations. This is called a sums of equations, and that's what you're going to be doing in exercise 1D. Okay, you're trying to look at them. You don't need to know what the graph looks like for this one. You're just analyzing. Okay, you're analyzing what's possible and what's not. Now that's the same thing with D. Before I tell you how to do D, I want you to also look at it and say, well, what's the conditions? And it's the same thing again. It's square root. So we're saying that whatever x squared minus 7x plus 12 is, we just need to make sure this doesn't end up being a negative. This is interesting because this question here is actually 1E. It's composite functions. It's an example of a composite function where you now have to look at the conditions and you have to try to make it fit. Okay. In my case here, I know what the answer is, but I want you to think about it. See if you can work with that with what I've just taught you. You have to make sure whatever x squared minus 7x is, it's not going to be a problem. Okay. That's what the implied domain is. So they don't tell you. You have to figure out what values can't it be. And I'm going to show you how to do D. Okay, but I'm just going to rub this section off here. Okay. All right, have a look. Let's have a look. This is the last example. For the examples in your textbook, and then I'll look at your textbook questions, see which ones are hard and whatnot. Okay. So let's have a look at this example 13D. Okay, this is one of your trickiest ones, and then you'll see more in exercise 1E. When I come back, I'll teach you more about this. But just keep in mind, it's all about conditions. You can sketch this graph and look at the domain and tell me the answer. But let's say if you can't sketch it, the skill that you're trying to work with is looking at the conditions. So here are the conditions. We know square rooting anything, this cannot be negative. Whatever x squared minus 7x plus 12 is, I know that's a quadratic equation, but whatever that number is, I can't have that being less than 0. I need it to be bigger than 0. Or equal to 0. Okay? And this is what you learnt in year 11. This is where it was tricky. Remember discriminants? Or remember inequations where you had to sketch the graph where x squared minus 7x plus 12 where it's greater than 0 and you had to write down the domain where that works. That's exactly what you're doing right now. Okay? Exactly what you're doing right now. Exactly. That was quadratics from last year, term 1. Okay? I think it was like exercise 3J or something like that in equations. So have a look at chapter 3 again if you want. But what you're really saying here is you just want to make sure x squared minus 7x plus 12 will not be a negative. Now, for me, if I were to do this by hand without a calculator, I like to sketch this graph first. I need to know what x squared minus 7x plus 12 is. So, in order to sketch the graph, I'll probably try to factorize it first. So let's see if I can factorize it. 12 can be made up of 4 and 3. 3 times 4, and I can have negative 4 minus 3 is negative 7. Alright, so that means I have axis-intercepts at 3, 4. It's a positive graph, so it looks like this, and a y-intercept at 0, 12. Okay, so there we go. That's what x squared minus 7x plus 12 looks like. Okay, I'm not sketching the square root of this, because remember, we already know the condition. This is what we are trying to satisfy. We're trying to make sure that we want to know what numbers, what could the domain be, so I mean what x values can I have so that x squared minus 7x plus 12 is always positive. So when we say x squared minus 7x plus 12 is always positive, we're actually talking about the y values because we want the y values to be positive. Because whatever x value we choose, I'm going to use a red pen now so you can see, whatever x value we choose, it's going to have a y coordinate that is positive. See, this is a positive y value, meaning that if I chose, clearly if I chose x equals 0, okay, if I sub 0 in, clearly the y coordinate for this equation is positive 12, which is what we have, yeah? And we can do the square root of 12. See, if I subbed in x equals 0 here, it ends up being root of 12. And that's fine. So yeah, I can have an answer like that. It's not undefined. That's okay. So the question is, where is it undefined? Where would it not work? And so in my case here, the only places that it won't work clearly is when the y values are negative. These values here, all these y values here that correspond to those points are all negative. If I have a negative, so let's say between 3 and 4, clearly if I chose 3.5, okay, that's going to give me a negative value. So x squared minus 7x plus 12, if I substitute 3.5 in, I should get a negative value. Okay, so I'm going to do it on my calculator in front of you so you can see x squared minus 7x plus 12. So I'm going to go back to this. I'm going to do define f of x equals to x squared, what was it again, minus 7 times x plus 12. See, if I did f of 3.5, watch, it's going to be a negative value. See? Negative 0.25. See, I knew it was going to be negative just based on the graph. I can tell that it's going to be a negative value. And what's the problem with that is if I subbed 3.5 into this equation here, in the original equation, I end up doing square root of negative 0.25, which we know that doesn't work. We can't square root a negative, so they'll be undefined. So what I can already see is I can choose any value for this f of x to work. I can choose any value as long as it's not between 3 and 4. If it's not between 3 and 4, if it's 4 onwards, all the y values are positive. All the y values here are positive. So what I'm trying to say is the answer clearly has to be from 3 all the way down to negative infinity, and 4 all the way to positive infinity. Anything between there, you can't square root it because the quadratic function is going to have a negative y value. Okay, so think about what I just said and try to sit on it. Think about this example. The answer for this question would literally just be the domain. The implied domain is, so the domain would be x is an element of, and we know it goes from negative infinity all the way up to 3, okay, union 4 all the way to positive infinity. It can take all those values, but it can't take any values greater than 3 and less than 4. Okay, so you could have done it this way as well. You can say element of R excluding. What do you want to exclude? You want to exclude, actually you don't want to exclude the 3. So don't exclude the 3. Exclude 3 to 4. There we go. Okay, so this is excluding. Yeah, I'm getting confused with the exclusion part. Let me just remember what I just said. So you're excluding, and this means, okay, out of my exclusion list, don't include 3. Yeah, no, that's correct. Yeah, these two are the same. So don't exclude 3 and don't exclude 4. Because in my exception list, I'm saying any number that you can have except for, now this is my list, in numbers between 3 and 4, but just don't exclude 3 and don't exclude 4. Okay, if I put a close bracket on it, it means also exclude 3 and also exclude 4. Okay, there you go. So that's my answer. But let's do this on a CAS so you can see what I mean. That it should be any value between 3 and 4 should not exist on the graph. Okay, so if I were to do this, define f of x equals 2. Now I'm going to do it square root of x squared minus 7 times x plus 12. Okay, we go to this graph, and I go up here, whoops, and I do f of x. See that? Between 3 and 4, which I can show you, menu, that was 3 there, menu 6, 1, so the x-axis, I'll show you, this has to be 4. There you go, 3 and 4. See what I mean? Between 3 and 4, it won't exist because the quadratic will become a negative and you can't square root it. Okay, so this is the graph, and you can sketch the graph and then tell me what the domain is. But the skill here that you're trying to take out is how to tell from looking at the equation. It's an analytical skill. That is very important. The skill to be able to look at it and say what are the conditions and think about it logically is what the examiners are going to be testing at the end of the year. That's what you have to know. So 1b, 1c there, but it started off with knowing what a function is, knowing how to describe it with your set notation. Once you know what a function is, you can now look at domain and range to analyze the implied domain. Which all of this is very important to 1e. Composite functions is what this was. Okay, and it's one of the hardest ones because, you know, a lot of students, we've been working with sketching and a lot of times we don't understand what we're actually doing. It's very important to understand what it means when we're talking about domain and range and how it affects when we put a negative value and all the conditions. Yeah? All right, so, you know, let that sit and rest in your head for a while. That example, that 1D, because that, as in that example D, I'm just going to clear up all this mess here now. And let's have a look. I think I've been recording for a while. It's probably been like 40 minutes or so. But let's have a quick browse of exercise 1C. Let's see the things that we can have a look at and how my examples have helped or will help you to do 1C. So it says state the largest possible domain and range for the functions defined by each of the following rules. Again, same thing. Sketch the graphs. You know, that's a quadratic, square root, semicircle, square root, quadratic again, and rectangular hyperbola. You can do that on your calculator or learn to do it by hand and analyze it. Yeah, and tell me the domain and range. The next one, question 8. Find the implied domain for each of the following. So again, same thing. Implied domain, you know, we know that the fraction denominator can't be 0, so I already know it can be any number except for 3. Because 3 minus 3 would give you 0, and you can't do 1 divided by 0. Okay, so the domain for the first one obviously would be x element of all real values except for 3. Okay, that's for the first one. So it's all about analytical here, or sketch the graph. I prefer you to analyze it because these questions, like E, F, H, maybe J, but that's like that's just a semicircle with radius 5, so not really J, but you know, a lot of us will get that confused. I, that was the composite function idea, so it's worthwhile having a go at I. So whatever I did before, have a go with that. K, I did that example before, you can try that. Here, same idea as the first one. If you can do A, you can do G. Yeah, we just want the denominator not to be 0. And instead of 1 value, now you have 2. Okay, so that means it can be all numbers except for when x is negative 1 and x is 2. See, if I'm looking at it, I'm just looking at 1 over x plus 1 times x minus 2. If this was a negative 1, this ends up being negative 1 plus 1, and this would be negative 1 minus 2. What we can see is it becomes negative 1 plus 1 cancels out to be 0, and you got 0 times negative 3. It still becomes undefined. So I already know, therefore, x cannot be negative 1, because otherwise it'll be undefined. But then, what about this condition? See, x minus 2, I know that if x was equal to 2, that won't work either. See, if you tried that, I'm not even sketching the graph right now, I'm just analyzing it. See, 1 over, if x was 2, you would have 2 plus 1, and this would have been 2 minus 2. So the issue with this one is you have now 3 times 0, and again, it's undefined. So the answer for G would be, where is it again? G would be x element of real values except for, and it couldn't be negative 1, and it couldn't be 2. Done. Okay, those are the two numbers that you can't take, but otherwise you can take every other value. E, you can sketch the graph or analyze it. Now, this one looks tricky because you've got an x squared minus 1, so f of x, I'm doing E here. You got x squared minus 1 over x plus 1. Well, the first thing I do is I try to simplify that into something I know, like a fraction like this. This is nice because you've got a constant in the numerator. So what I would do is actually I'd factorize both top and bottom. Bottom is already x plus 1, but x squared minus 1 I can factorize using difference of perfect squares. It becomes x squared, x minus 1, x plus 1. And we can see that x plus 1 divided by x plus 1 cancels out to be 1, and you're left with x minus 1. Okay, so clearly this can be all real values, but what's the condition? Don't be tricked here, because yes, it looks like if you cancel it out, it's like x minus 1, fine. X can be any value. F of x is all real values, but that's not true, because that's what you've done is you've just changed this equation to a simplified equation. Okay, and that that is disregarding a rule. You've omitted a rule, or you omitted some sort of condition. That's why you always got to go back and say fractions. What's the conditions of a fraction? You can't have the denominator equal to 0. So again, look at the denominator. That's x plus 1. And we know we can't have -1 plus 1. So if x was equal to -1, that's an issue. Okay, so I wouldn't say x is an element or real values, because it can't be every single value. It can't be -1. See, at -1, I would have 0 in the denominator, whereas in the numerator, I have 0. 0 over 0 is undefined. Okay, so f of -1, what I'm trying to say is if you had -1 squared minus 1 over -1 plus 1, this gives me 1 minus 1 over -1 plus 1. 0 divided by 0 is not 0, it is undefined. Okay, so because it's undefined, we know that it can take any value except for -1. Okay, so that's E. But that's the skill. Do the same thing for H. Okay, so there's two conditions there for H. There's a square root symbol and there's a denominator. So there's two conditions that you have to work with. Okay, so the training here is to visualize, but at the same time to analyze the equations. That's question 8. You go to 13A. It's all about sketching. So state the range. Again, you can do this on your calculator. Do a hybrid function. So if I just show you, if you just actually you can do it. Should I do it? Yeah, okay, I'll do it here. So define f of x equals 2. Now in your catalog, so see on the left hand side here, catalog box, wait, not the catalog, sorry, not the catalog. Next to the catalog, this button here, you can put in the common uses, and here we've got 3 that we want to use with conditions, with the commas. So I'd select that, and a number of function pieces, I've got 3, and you know, I can type in x squared plus 5, and I want x greater than 0. Just in case you didn't know where to get the greater symbol, control equals, and that's where you can get your greater than or less than symbols. Okay, and you can go down to the bottom and do 5 minus x, and then you say it's between -3 less than or equal to x less than or equal to 0. And then you go to the next one, it's 8, whoops, not 7, 8, and x is less than -3. Okay, define it as a function, go over here, and if I did f of x, which is there, oh, it's because the window's a bit small, so I just gotta zoom out a bit. There should be 3 parts to this. What are my 3 parts? There you go. So my 3 parts, if you can see, these are my 3 parts. You've got that point to this point. So between -3 to 0 and 0 onwards. So 0 onwards, I've got a quadratic equation, because you see that curve, it's a quadratic equation. This is a linear equation, but it's a negative gradient. And this is a linear equation, but a horizontal line, anything less than 3. So there's 3 parts there, yeah? So you can see, if I go back to the equation, see that's my horizontal line, less than -3. So if you draw out your lines, -3, this is your 3 portions. Remember in class I was showing you that other video, 1C, have a look at it again. -3, you're just sketching 8. So you know, you do your 8. Up to this point, it's open circle. And then you got 5 minus x, that's a negative gradient. Work out the axis intercepts here. So, you know, when it goes down, it's got a, what's that? The y-intercept is at 5. So it goes through here at 5. And it's a closed circle, and that's a closed circle there for those 2. Doesn't cross through the x-axis because it stops at 0. The domain goes from 0 to 3. And then from there on, I've got x squared plus 5, which means it's a quadratic that shifts up by 5. Okay, but it's only from 0 to infinity. And there you go. Okay, that's my hybrid function. Y, x. And then state the range. Well, clearly the range is from 5. Y is an element of 5 all the way to infinity. Voila. Okay. Now, for those students who, and you can have a go with these ones, you know, you f of 0. So 0 is obviously less than 3. So it would be, if it's less than 3, it will fall under this category. So when x is less than or equal to 3, you use this equation. When it's greater than 3, you use that equation. So you sub this one in here. -4, you sub in there. 4, you sub into that equation. A plus 3 in terms of A. All you're doing is you're just substituting this into the equation, and you want f of a plus 3. If it's a plus 3, well, which one do you sub in? Well, clearly 3, if you add a, it has to be more than 3. So you obviously substitute in this one. So d would be f of a plus 3, and you're substituting into this one, so it's 1 over, instead of x, you now have a plus 3. Okay, that's what it means. Now, f of 2 times a in terms of a, 2 times a, well, a could be, which one do you sub that one in now? Does it ever say what a is? I think this would mean now, okay, so if I were to do this, I reckon you have to change the conditions as well. So it's 2a, this will now be 1 over 2a, and the denominator would be 2 times 2a, because it's replacing the x's, and therefore this would be 2a greater than 3, and this is 2a less than or equal to 3. So therefore, simplifying it down, this would now become 1 over 2a, and this becomes a is greater than 3 on 2, because I just divide both sides by 2. And this is 4a when you have a is less than or equal to 3 on 2. Okay, that's how you answer that question. That means for this one, you do exactly the same as well. You do a plus 3, and you replace that with the x's on the condition as well. Okay, there you go. And it'll be the same thing for this one as well. Okay, that's question 14. And then now finally, odd, even, and neither. For those who, for students in class 12D, this is where I haven't taught you what an odd and even is, but you can watch the other video and it tells you. And for those who didn't really understand from class 12E, those who were still confused with the odd and even, all I'm saying is this. If you have the original function, okay, and you substitute negative x in, and it ends up being the same thing as the original, this is called even. Okay, this is the only test you have. Okay, if you put in a negative x and it ends up being the negative of your original function, this is odd. If it doesn't fit in either, it's neither. Okay, so let's pick out one. Let's do c. Okay, so if I do c, now the original function, f of x, the original, is negative 4x cubed plus 7x. Okay, now I'm going to put in, if it were to be odd, see, odd says that if it's negative of f of x, so negative of f of x would just mean that you're doing negative of negative 4x cubed plus 7 times x. That's what the negative means, right? Then what you expect is it should be this, 4x cubed plus 7x. Okay, so it was this. If it looks like this when you put in a negative x, that's even. If it looks like this, it's odd. If it doesn't look like any of those two, then it's neither. So how do you test it? We'll do exactly the test. So what's the test? Sub in a negative x. So that's what I'm going to do. Now I'm going to substitute negative x into the equation. Okay, so this now becomes negative 4 times negative x cubed plus 7 times negative x. See the difference? If whatever this answer is right now, if I simplify it, if it looks like the red one, it's even. If it looks like the blue, it's odd. If it doesn't look either, it's neither. Okay, so let's have a look. Negative x cubed becomes negative x cubed. Times with negative 4 becomes positive x cubed. This is minus 7x. So together, you now have positive 4x cubed minus 7x. Now, which one does that look? It doesn't look like this one, because that has a negative 4x squared there, after 4x cubed. And it does have 4x cubed here, but that's a plus 7x. So this is neither. Okay, the answer for this one, C, is neither. I'll do one that I know is going to be even. So let's try B. Okay, B is going to be even. So see, f of x, I'm going to do color-coded again so that you can see. F of x is equal to 2 times x to the power 4 minus x squared, right? And if it was to be odd, odd would have a negative of f of x, would mean that I'm going to say all of this is negative now. Okay, I'm going to put a negative on the outside. See what I'm doing there? I'm just saying if this was now a negative and if that was a negative. So what this ends up being is a negative 2x to the power 4 plus x squared. True? If you times them 2, times this by a negative, times that by a negative, that's what you'll get. Okay, so now to do the test. See, if the test ends up being like the red, then it's odd. If it's like the blue, then it's... Sorry, let me fix that again. If it's like the red, it's even. If it's like the blue, it's odd. Okay, so let's do the test. F of, now the test is sub in a negative x. I'm going to do the same thing. 2 negative x to the power 4 minus negative x squared. So, let's see. So, by mathematical definition, let's check this. This becomes 2x to the power 4. This is minus positive x squared. Now, conveniently, this looks exactly the same as the red. So, therefore, even. That's all you do. 3 steps. Yeah? The original, the odd, so even, possible, odd, check. Possible, even, possible, odd, check. That's all you're doing. Okay, question 19 is just for odd and even. Okay, so that's exercise 1C. I'm just going to go back to the very front so you can see what we've actually covered. My screen's not working well, actually. I'm just going to go all the way back just to remind you what I tried to teach in this last hour or so. So see, we went through exercise 1A, set notations, interval notations, learning how to describe domain and range. Then 1B talked about function relation, the 4 types of relation, which I used in this exercise for the first part, and implied domain was part of it as well, reading and analyzing. Then I just finished off with hybrid, odd and even functions, that's for 1C. I know it's quite plenty already for you to work with, but 1B, 1C, very important. The hybrid and odd and even you'll pick up easy, but what's the most important one to take out is what a function is, types of relation, implied domains. So implied domain means you have to know how to read the equation. You have to know the properties of a function. So it ends up going back to functions again. Okay, that's what I want you to practice for this exercise. I know it's a long video. Fantastic for sticking with me. You know, you can pause the video while you're watching, and you just work with it. You know, just work it as you go. You know, just see. You can watch it all in one go, and you can watch it again. I don't mind. It's just here for you. Take your time, learn it. Be smart about your learning. You know, pick 1 or 2. Like the questions I just done, I just picked 1 or 2. I just try to get you to feel what it's like doing exercise 1C, 1B, 1A. What are you trying to cover? What have you learnt? Those are the questions you want to ask yourselves. Okay? Fantastic year 12s. Really proud of you guys. If you're watching this and working hard, I'm really proud. I'm going to keep trying to make these videos. So I'm going to make another one for 1D in case you picked up this pretty well. You want to move ahead. But I do know it's getting pretty late and I got to go to dinner soon. So I'll make another video and then I got to help my year 11s as well. So good luck. All the best wishes. And I hope I don't have to go into many other camps. I do prefer to be in class to teach you guys and get you well prepared for the year. But when I can't, this is what I'll do for you guys. Yeah. All right. And again, if you have any questions, try to help each other. Discussion folder. It's there for you. Yeah. I'm just going to close this video. So I'm going to do 1D. Okay. I'm going to close this video. Let's see how long. I reckon it's about an hour. You won't be able to see it. Just look at the time.